All right, so give this a shot. We will continue to explore the Haber process for ammonia. Calculate delta G at 298 for the reaction mixture that consists of 1 ATM N2, 3 ATM H2, and 0.5 ATM NH3. Yes, sir. 8 pi. 8.314. What's that? You're going to put in the values there for K. So this is a different way to find delta G. There's no delta H, there's no S, there's no table, but the equilibrium expression and G naught relate through that relationship. And please remember that R is not 0.0821, it's 8.314. The coefficient. You dang well bet it is. It becomes the exponent. You're welcome. That's what I'm here for. And to eat this shake. Maddox.
The shakes there are the best things there.
The best thing? No, they're porterhouse. Hey, you should talk less and be done with this problem already. Way done. Way done. Yeah. Yes, everyone listen. The 8.314, it is joules, mole, Kelvin, or something like that. So everything cancels out except for the joules. So when you got a big number, probably, did you get a big number? Yeah. What was it? 11,600. All right, so it's 11.6 kilojoules. Then it's not that big of a number. It's fine if you write joules. Okay, she says she might be wrong. Soraya, do you have a number? Grace, you got 11?
11,100?
Yeah.
Yeah, that's what I got.
Okay. Okay. Well, you got to find some, friend.
Yeah, you don't have to change it to anything ATM because
No.
it's 8.314.
Nope. That they all, the unit of K is unitless. Well, if you do the chemistry wrong, you will get the wrong answer. Nothing personal, of course. Let's try this. I've never done it this way. That's kind of ugly, but we can figure it out together. Okay, not gonna focus. They are amazing.
Are you in?
It's products over reactants.
Does being in radiant matter for this class at all?
Not really. I better move this over here. Oh, I can't move it over there. What do I need to do here?
It's actually not that bad. But we moved the test back for it. Yeah. So we have like a month extra.
For what? Wow, we need a month extra here. Just to get over the amount of fights Reese and Cooper have had.
I'm not fighting this sucker anymore.
That's like 3 weeks.
There was a moment in time though.
Reese was feisty. I don't know what got in her Cheerios, but she just needs to watch that video you recorded and she'll be like, oh, I'm never picking on that beautiful man again. Yep. Okay, here we go.
We want to see the Cooper video.
You'll see a video tomorrow. It's probably even more beautiful. You didn't have to make 2, but you could, and you should, in my opinion, have made 2. Right, that's for sure. Okay, equals negative R, which is 8.314, right? Times temperature, which was 298, right? And then the ln of K. Now K, that was kind of dumb. K is point what on top? Just the piece of it, NH3's concentration. 0.05 squared, right? Oh, lordy, lordy, lordy. There we go. There we go. 0.5 squared over what?
3 raised to the third. Yeah.
3 cubed.
Yeah. Yeah, and then
And
by 1, but that doesn't matter.
1. Okay. No pun intended. You plug these numbers in, you take the ln of it, and then you multiply, right?
Yeah.
And you ended up with 11,600 and something.
Yes,
All right. And these were joules, which you are certainly allowed to use as your answer. If there's a follow-up question, which there usually is, where delta H or delta S is involved, if you find delta S in a table, it's in joules, but delta H is in kilojoules. So you got to be really careful. So you could also get a right answer if you put 11.6 kilojoules. Fair enough? Yeah. You asked yesterday, and I do not know. Someone asked yesterday. I'm not a math guy. It's some sort of relationship, but I've never been good at relationships.
Me either, David.
Gotcha. All right, here we go. Next up, I don't even know. Yes, Kale.
But where did you get the R?
R is, it's a universal constant. We used it when we did gas laws, but that was for ATM and temperature and volume. This is when we can relate it to the kilojoules for those moles changing. It's a little weird, but it's just,
Always that value is negative.
it's not negative. It is just 8.314. The negative was in the actual problem, or sorry, the equation. But yes, for chapter 19 problems, it's always 8.314, but for PIV NERT, it's 0.0821. Am I supposed to what?
Have those answers out.
I don't even know if I'm going to give you this problem. Let's see. Yeah, so I wasn't going to do it. Really, I want to move on to the next chapter, I think. Yeah, chapter 19 is fast. It's as important as any chapter like 8, 9, 10, 11, 13, 14, and it's less than 15, 16, 17. If you're only going to study one concept, make it equilibrium. Now, by the way, if you're only going to study one concept, go ahead and put your $55 in a shredder and just let it go away. Because, yeah, I wouldn't do it. If you've been behind, if you're lost on the last 3 chapters, they are the most important 3 chapters of the whole book. Not this one, but the 3 before it. Super important for your AP score. Yeah, after grading your tests, it didn't go really well for most of you.
Last chapter was the hardest chapter I ever had. But the other chapters I feel fine.
Well, last chapter is the hardest chapter, so that's a complete normal feeling.
Yeah. Like, I'm confused on when to look. I'll just come into the times.
Yeah, you can come in, you can get help, we can raise your grade, we can do whatever we need. There's going to be plenty of time after the AP test to do whatever you want to try and get an A. I wouldn't panic about that score. Yes, it sucked for a lot of you. The high score was a 94, I believe.
Caitlin, hey, gotta go.
There were 2 of them.
I don't know who else.
Not to burst our bubble, but it was there was 3 or 4 people in the 90s, and then 3 or 4 people really low, really low.
What was the lowest score?
Oh, I'm not going to say that. Person will feel stupid. But it was you, John. All right. There was one significantly lower than that, John. So don't worry about it. Yeah.
Yeah, technically it's
Technically, I win.
Technically, it's a tie for last place for 3 people.
Oh, 3 people on a
Oh.
secret test.
Yeah.
Yo, who knows who's the club?
I feel very upset with my score, but I feel better about it now.
Okay, there's one more other person who's sharing the 0% with me.
The 0%.
So we can do a 19, chapter 19, chapter 20 together.
Yeah.
We should review tomorrow. Actually, I don't know.
Okay, here comes chapter 20.
Are we doing them together? Is that what-
Yes, that's what he just asked. Chapter 20 is electrochemistry. This is really, really hard. I'm not going to lie.
Oh,
But the good thing is they don't usually test you on the hardest parts of it. And I'm not going to bet, but if I had to bet, there's no way this is on the test. It's the last unit for every teacher in the United States of America. Half of your peers have never even gone to school buildings this year. Half of your peers have never been in a school building. Like I think this is just my hunch that yes, the test will be as long as it was before COVID, but it will probably not hit these last chapters very hard. I could be super wrong, but that's my bet. Because if you watch the news, it's still on the news. It's like schools are about to restart. You're like, what? This is my 8th freaking month. And they haven't even gone back yet. So
All my friends in Minnesota.
no Minnesota.
Yeah, my last school, they've been in the hotel.
Man, Minnesota cannot catch a break. Millions and millions and millions.
And we had a school basically.
All right, here we go. Shh, 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 shh. Electrochemistry, pretty tricky. Not my favorite chapter either. I'm going to move it to this screen. Oh, no, I'm not, because this got disconnected, of course. Why would I want something to work? The technology is just driving me crazy lately. Not as bad as it was like a month ago, though. Nope, they just poof, no moss. Oh, that's awesome. How's that even a thing? Oh. Okay, here we go. Electrochemistry, there's basically like 2 or 3 huge concepts on this one. I am recording the wrong screen. They are beautiful. This is probably technically bad because you'll probably now be like, oh, he is as good looking as Cooper. Maybe I'll vote for Derek too. That was the plan. It worked perfect. We were, no, Dixie Rock. That thing? Oh, yeah. Like, oh, sorry, wrong screen. Both of them are running. Is your brother running too? That's funny. It's the Davidson Lloyd show. Okay, here we go. We've done this part before. In electrochemical reactions, electrons are transferred from one species to another. This is oxidation reactions. Remember that part? Yeah. So this should be review. All right. So simple example is when just a basic ionic compound is formed. You have sodium, which is a loser because it's a metal. It loses an electron to chlorine, who takes it because it's a non-metal. All right, if you've noticed this wasn't balanced, I apologize. So you got 2, a 1, and a 2. Sorry about that.
What is the 0? Oh, it's the electron.
It's not their electrons. Shh, I'll tell you. What? Because someone wasn't quiet last year, 2 years ago, actually. It was very appropriate for this moment in time, though. Okay. The zeros, the plus ones and their minus ones are their charges, or really now we call them their oxidation states. The oxidation state or charge of a neutral atom, not neutral, sorry, an elemental atom is always 0. In an ionic bond, a metal is always a positive number equal to the number of electrons it lost, and the non-metal is a negative number equal to the number it gained. And we've done this. So I'm going to move on. Now, just real quick though. Sodium lost an electron, but please notice it lost an electron twice because of that. You okay with me? All right, now watch carefully. Chlorine gained an electron twice because of that. They always will balance. Whether it comes from the subscript or the coefficient, if your electrons exchanged don't equal each other, then you did something super wrong. This is a redox, is what we call it, a redox or oxidation. All right, that's a pretty picture of a battery. Batteries run off of oxidation things. Okay, I believe we did oxidation numbers before, didn't we? Okay, so this is a review. So in order to keep track of what loses electrons and what gains them, we assign oxidation numbers or oxidation states. There are a few rules that we've already gone over. Let's see if they're written out here. No, where are they? They got to be here somewhere. I don't want to spend all day. All right, we'll go backwards, but for now, we'll go here. To find those numbers, we follow these rules. If it's an elemental form, it has an oxidation number of 0. I mean, it doesn't have a charge. It's neutral. It's what it technically means is its number of protons and electrons are equal to each other. All right. The oxidation number of a monatomic ion is the same as its charge. So like if we had K and it lost 1, we'd say it's a +1, or we'd say this oxidation number is also +1. And that's very, very, very common. Good. Okay. Non-metals tend to have negative oxidation numbers, but especially in oxyanions, they can be positive. But most of the time, they'll have a negative value. And then this is the number one thing that kind of drives a lot of what we do. Oxygen has an oxidation number of -2, except in the peroxide ion in which it has a number of -1. And this is super rare. So just please memorize oxygen is always a -2. If it's pure oxygen though, that's an atom. So that would be a 0. All right. Hydrogen is a -1 when bonded to a metal, which we hardly ever do in this class. So really, please memorize that hydrogen is a +1.
How often is this unit tested on other AP tests?
You probably get every 3rd year, you'll have something from this chapter. Mhm. And they can be really easy or they can be really hard.
What are the 8 chapters again, like a breakdown of
15, 16, 17. They're the ones that, it's tricky. Equilibrium is the only subject that is 100% guaranteed to be on the test. Now you'll have a ton of others, but that's the only one that's promised you it will be. Oh, and Grace, this was taken at the Dixie Rock. So close, but not at Snow Canyon. Okay. I already have that. So right here, wow. Did this change? I'm so confused. Yeah, it did. Okay. So this stayed the same, but it goes right here, right? Fluorine always has an oxidation number of -1. How come fluorine always gets what it wants? It's the Cooper Lloyd. It's a handsome devil.
Maureen's looking really good.
All right. Then the other halogens have an oxide number of -1 when they are negative, but they can have a positive number if they're with oxygen. And they will be. It's really weird. Like if you have ClO3-, then this chlorine right here is acting like a +5. So it gets a little bit weird. We can show you, I can show you why.
I don't remember. Did you have to burn oxygen?
Yeah, we did this. I guarantee we did. So if you look, if this is a -1, then all this math has to equal -1, right? Things I know to be true is that an oxygen is -2, but there's 3 of them, right? So the total charge oxygen brings to the table is -6. So chlorine must bring what to the table?
Oh,
+5.
oh, okay.
There's oxygen. So oxygen said like it's element form is 0, so that'd be like diatomic.
Yep, diatomic oxygen would be 0. Fair enough. Okay. All right, the sum of the oxidation numbers in a neutral compound is 0, but the sum in a polyatomic ion is the charge of the ion. So like how I just made that one equal -1, it's because chlorate is equal to a -1. All right, fair enough. Okay, I'm going to go backwards now. Okay. Yeah, there's very high likelihood I cut these from that chapter. All right, so zinc is a 0 because it's just a solid. If it said AQ though, like there, it wouldn't be a 0 anymore. Because when I find the element zinc, it's not in a liquid, it's not dissolved, it's a chunk of metal. 0. H plus, go ahead.
It would have to be a solid or a gas or a liquid because that's only that it can't be aqueous.
It would not, aqueous means it's broken into its ionic forms. All right, so H plus, in this equation, we got rid of the spectator ion. This is zinc plus hydrochloric acid. So if it looks weird, you're like, that wouldn't just react. It's because whatever, we got rid of chlorine. All right, H plus is a +1 because H is always a +1, just because it is. Over here, zinc has lost 2 electrons, and the 2 hydrogens, this 2 right here, the 2 hydrogens gained 1 each. Did I lose a lot of people there? Oh, it was a text? It's okay. All right, now look, this doesn't seem to work out, but if we balance it, like these things aren't balanced, but if they are, if we do balance it, it balances out. We have 2 of those, 1 of these, so we have equal pluses, then the zeros, they're accounted for in the minuses. Now let's go to one that's more complicated. No, it's not. All right, here's some definitions you must know. And once again, these were in the other chapter. A species is oxidized when it loses electrons. What? The substance. You could say like the atom or the ion or the compound, whatever. That's not what I want. All right. So if you lose, you are oxidized. If you gain, you are reduced. And that vocab really bugs people. How do you gain something and you get reduced? It's a negative. You gain a negative, you are reduced. I know it's weird. We need to go back in time and fix all this crap. Stick with me. You're welcome. It's right there, right above the periodic table. Probably quote Reese and say, Cooper, shut up.
I've never told Cooper.
Only in the last 5 minutes.
Yeah.
No, it usually goes like this. Cooper, quit talking about Bert's wife.
Yeah, that's what I
There you go. Same thing. Okay. So this is where it gets a little more complicated. Please listen. The thing that is reduced is called the oxidizing agent. The thing that is oxidized is the reducing agent. It's not hard. Yeah, it's just like that. So if the thing was oxidized, it let reduction happen. If it was reduced, it let oxidation happen. So once you find one or the other, just don't call the reduced thing the reducing agent. It's opposite how they line up. I just did.
We're like 1-year-olds.
Explain it to us like we're still in the loop.
Here we go. Woo. What does reduced mean? Shh, 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 shh. It gained, right? It can't gain unless something has oxidized. So if you reduce it, it caused oxidation to happen. If you oxidize it, it caused reduction to happen. That means it was reduced.
So oxidizing is
Because something can't, this thing can't lose unless it went somewhere. They have to have pairs. You have to pair them up and they have to be opposite. So, I mean, it's a little confusing just to look at, but just remember they're opposites. If it was oxidized, then it's the reducing agent. If it was reduced, then it's the oxidizing agent. So H plus oxidizes zinc by taking electrons from it. All right, it took it from it, so it was reduced, or it was the thing that caused oxidation to be possible. Zinc reduces H plus by giving it electrons. So it's just the way you look at it. Okay, drawn up here. We have zinc, which loses electrons, so it was oxidized. All right, we have hydrogen, which it gained electrons, so it was reduced. So this means this was our oxidation agent. This means this was our reduction agent. Right. What's that?
H plus is the one that gains electrons.
Right.
So would that be oxidized?
This was,
H plus is the oxidized, right?
this is reduced, you're right. So this is the oxidizing agent, sorry. So this was oxidized, so this is the reduction agent. So find who was oxidized, and they're the reduction agent. Find who was reduced, and they're the oxidation agent. Okay, it's just like conjugates, and we already did those, so that's why I'm flying through this. Oh yeah, that's gonna be fun. Okay, here we go. This is what we'll do here. HNO3 plus zinc goes to ZnNO3 2 plus H2.
You want us to find the oxidizing?
Yeah, we'll just do it together. We'll do part of it together, then I'll let you do the rest. How do I know? Yeah, you need 2 of these. And then you're balanced. How do I know that zinc nitrate and HNO3 were both aqueous? Because I memorized that's a strong acid. And, say it again. And I know NO3 always dissociates. Okay. Now, I would recommend before you do this, cancel out what will be the spectator ion, because it has nothing to do with anything, right? So that'd be nitrate. I'm just going to erase it. You okay with that? And I'm going to turn this to a plus. I'm going to erase this and turn this to a +2. Fair enough? All right. Then, will you assign the oxidation numbers? Who was reduced, who was oxidized, who the oxidation agent is, and who the reduction agent were. All right, let's go through it. We got to wrap this up in 2 minutes. So H plus was a +1, right?
Yeah.
It got more negative. I know 0 is not a negative, but it's negativer than 1. So if it became more negative, it did what?
So that it is the oxidizing agent.
All right, so it gained electrons, right? So that means it was reduced, or it was the oxidizing agent. So then this must mean that this lost, and that makes sense because it came more positive electrons, which means it was oxidized, which means it's also the red agent. Okay. Leo, the line says GR. Good job. Lose electrons oxidized, gain electrons reduced. All right. We're going to learn how to balance oxidation reduction reactions tomorrow. Now listen, I'm going to teach it, and then I want you most of the time to not even try it on the AP test. I know. You'll see why. It's a time consumer, and you really have like a 10% chance you even did it all right. So I'm going to teach it because it's my moral obligation. But if it's in the free response of your test, try it. If it's in the multiple choice, guess and go. It's not worth the 3 minutes it takes to do it.
Because it's equal.
Yeah, you have just as great a chance guessing most of the time as the 3 minutes.